Hi, everybody, and welcome to yet another recorded Zoom interview. This time, a special guest from the foothills of the Sierra Nevada in California. Sarah, what's your town and what's the weather like this morning?
I live just below Auburn geographically, and it's a gold rush town in the foothills. And it's supposed to be a hot, hot day here, mid 90s, but then we're in fall mode. So by Friday, chance of rain and 72 degrees. So, it's
Nice.
California sliding into fall. And,
Good. And
uh,
you've commuted to University of California, Davis for many decades at this
Many
point?
decades.
Yeah. When did you
I
start
would
then?
say I'm semi-retired, so I don't go every day.
Okay, okay.
Yeah, I don't go
Um,
every day, but
Okay, well, thank you. It's a pleasure to have you here. This is viewers. Can I talk to you just briefly here? This is Dr. Sarah Roeske, and if you've been following the YouTube channel, I did two interviews with young Trevor Waldine, a professor in South Dakota. But Trevor studied under Sarah and got started in Alaska tectonics under Sarah's tutelage. But Sarah, we're going to you today. What was your first field season? When was your first field season in Alaska? And have you been going every year essentially since then?
oh, okay. My first field season in Alaska, I was an undergraduate, I will
Yeah.
state it,
Yeah.
was 1979.
1979.
Yeah, so you can do the math.
Yeah.
And I was a college student at Middlebury in Vermont. I had the amazing good fortune to be part of a group of crazy young people who got a grant from NSF back in the day. And we spent 2 months in Alaska doing field
Wow.
work.
Wow.
So, needless to say, I was hooked.
Yes.
And I haven't gone every year since, but I've lost track. It's well over 30 field seasons. I had also the very good fortune to work with people at Santa Cruz who were in the 80s, were deeply in the Alaska tectonics world, multiple faculty. So that sort of set the tone.
It sets the tone, and that's exactly why I'm coming to you so early. So, viewers, a little bit more directly to you. The context for this discussion is I'm a rookie thinking about Alaska. I'm going up there next summer. I'm on a new grant with Michael Eddy and Ken Ridgway from Purdue University. All I know is that we're going to the Talkeetna Arc, and I guess that's the central focus. I don't even know where the hell that is, but I want to do the entire state somehow this upcoming winter. And Sarah took the time to watch the little workshop thing that I did a couple weeks ago announcing Alaska A to Z. And she's also seen the Trevor conversation. So Sarah knows where I'm coming from, and I'm wanting a little bit of guidance, or we can just kind of play off of each other here and there. So let's start, Sarah. I was thinking maybe of somehow involving the San Andreas Fault as a major strike slip fault. It seems so elegant and so simple, and then I would just kind of go up to Alaska and start using the same kind of piercing points.
Yeah.
Have
Yeah.
you
So I
have you
saw that.
tried that? Yeah.
Yeah. So when I watched that conversation you had with Trevor and you brought that up, I was like, bingo. I actually use it because it's not simple. And it's in my backyard, as it were, sort of backyard. Up in the foothills, we're not in the fault system, but
Yeah.
anybody who knows Western North America tectonics knows San Andreas and its faults are very active. And do you want me to share the screen with that picture?
Let's do
Or do you
just a
want to
couple
just talk a
more.
little bit?
Yeah, let's do a couple verbal things, and then we'll go to your
Sure.
slides of the San Andreas, and then we'll go where you
Yeah.
want. Can you tell us verbally why isn't it that simple? It seems like such a simple,
It's a
like
plate boundary,
nice.
right? Why isn't
Yeah.
it just like, yeah, Trevor showed that great slide showing, it's complex how faults move in a continent when they start, but if it's an oceanic plate boundary, it's very well behaved. But
Yeah.
you also had that discussion of it's very well behaved because it's an isotropic system when it's an ocean plate. You're
Hmm.
starting out with this nice even layer cake, and you'll have some pre-existing fractures, but not many. And then you hit continental crust, right? And you always have inheritance, no matter, there's always inheritance.
Yeah.
And so you end up with, in something like the San Andreas system, a lot of faults that are in fact active all at the same time. And we don't fully understand how much of that is controlled by inheritance
Hmm.
versus other processes because it is a transform and it's connected at both ends. Like Trevor's model, he showed where you have, the difference with an intracontinental fault forming within the continent and a transform, you have a plate boundary at both ends. You have triple junctions. And California, the San Andreas has a triple junction in the north, and then it sort of devolves into an oblique rift in Baja California. So
So those,
for I don't know if your viewers are familiar with the Mendocino triple junction.
I
Yeah,
think they are. Most of
they
them are.
probably are.
Yeah.
Yeah, yeah.
So there's dozens and dozens and dozens of strike slip faults in Alaska. Some of them are major, some of them are minor, I assume, but none of them are plate boundaries.
Well, that's probably correct. Some
Okay.
of them probably started as plate boundaries. In fact, I would argue all the major strike slip faults we have now originated as plate boundary faults.
Okay.
And that gets back to your question why some faults get reactivated.
Yeah.
And the word came up in your conversation, and that's a big topic that's been studied by a lot of people for a long time. And it's a big problem in seismic hazard, right? So the New Madrid fault in the middle of the country, like
Mm,
what's up with that? We have
right.
lots of faults all across the US. Why does the New Madrid go occasionally? Or in Charleston, South Carolina? I mean,
Right. Right.
God forbid, why do we have huge earthquakes in Charleston, South Carolina?
Well, that felt
So,
big that all major strike slip faults potentially were plate boundaries originally. I'm going to have to think about that one some more. I like it. Let me try to do one more kind of major kind of thing from my point of view, and then let's go to some slides. How about that?
sure. Yeah.
My kind of working thought this winter is that maybe I somehow get down to like I like using colors. I like
Sure.
using colors to
Yeah.
kind of as references to our discussions, and it helps me kind of find some major stories.
Mhm.
Like I almost want to color the state of Alaska with like six or less colors, and having some of those major strike slip faults, the Denali, et cetera, as kind of packaging these different colors, whether that's one old North America and one's Rangelia composite terrain or whatever. Has that been done to try to
Um,
simplify all those terrains to, let's say, six or less major entities?
yes. So I've done that.
Okay,
And I think I shared a slide with you of
you
that.
did. You did. I'm kind of setting you up, but yeah,
I was going to say thank you. Thank you very much. I actually, didn't include that sim uber simplified one in my slide deck because I've got
okay.
groups beyond that.
Yeah.
That's that's for geophysicists. No,
Ha
but the reason I say that is all they care about is, is it continent or is it ocean? That's
Yeah, I see. I see.
right. And I'm oversimplifying, but
Right.
where I'm going today in general is the geophysics. My work with geophysicists in Alaska has really presented to me a way to think about the whole state. And it's because they think about how does crust to form. And
Mm-hmm.
in that sense, you really care about, strength, and ocean plate material has a very different strength than continental. And so that kind of sets you up as a framework. So yeah, a lot of what you're thinking about for me, I'm thinking about how does both the modern tectonics and the ancient tectonics, what's sort of an overall theme that's controlling what's going on.
Well, good.
And
Yeah.
so anyway, so
From
getting back
your
to, you want me to start? We could either
Let's
start
do
with
it. Let's do
standard.
it. And we'll go however you want, but you're
Okay,
coming from both the research side and the teaching side. You've been teaching about Alaska tectonics for a long, long time. So
very long time.
I'm looking forward to what you have for us. And I think let's just wonderful. There we go. Six or less. Love it. Yes.
I think it's six or less. It's a few
Yeah.
more than
Something
six,
like
but
that.
we can simplify that.
No, this is great.
Yeah, I like this for exactly the reason you said. It's
Hmm.
the simplest version is I color all the blue the same.
Yes.
So you can visually with your eye lump all the blue,
Huh.
and that's
Okay.
all continental material. I mean old stuff.
Old stuff, Laurentia, that sort of thing. Okay,
Mm,
good. Yeah,
So I color coded it by whoops, back.
good.
Uh, okay, so unfortunately, this I'm trying to figure out. My screen's partially hidden by your.
Well, if you want to go to your kind of the other
No, that's
presentation, that's
good. This
fine.
is good. I cleaned it
Yeah.
up a little.
Okay.
Okay, we're all cleaned up now.
Good.
Okay, so the this color of blue is really the only bona fide Laurentia we're sure of.
Okay.
Most people would say Arctic Alaska and Farewell, this other shade of blue,
Okay.
are are broadly what we call Baltica. So they came from what is now in Europe, basically,
Mm-hmm.
or
Mm-hmm.
Russia,
Okay.
Eurasia. And so the reason I like this point is this is somehow a major boundary through here, separating things that always were, well, we think. This is all very controversial,
Sure, sure.
but I think most people would agree this is bona fide North America and it's craton. And there's good geophysics to show, like 3 billion, 2.8 billion, 1.8 billion rocks.
Yes.
And they're a stable platform over here. But then you come in here and all this is all basically extended version of North America. But it basically has really nice ties to North America. So we're going to
Mm-hmm.
call this all Laurentia.
Okay.
And then everything else is what we call suspect.
Everything else, including the AA, the little darker
Arctic
blue.
Alaska,
That's
yeah. So
yes.
Arctic
Okay.
Alaska, the Brooks Range
Hmm.
has some very old crust, Proterozoic. It's been highly deformed. All of this is high grade and blue schist and locally eclogite.
Ah,
So we have subduction complexes appear.
okay.
Basically, this is crust that collided with an arc in the Mesozoic and stacked up. So you've got these beautiful imbricate stacks, basically North Virgin. Of course, I'm pointing at my screen, which you can't see. So where the arrow is,
Yeah.
you can probably see there's some topography in here.
Yeah.
And then it goes to the flat northern shelf. This is sadly why they exploit it for oil, is because of that excuse me,
Yeah.
this collisional event stacked up and make the perfect, like the Canadian Rockies and the US Rockies are very oil-rich areas. You take a carbonate platform
Mm-hmm.
material and shale and sand and you imbricate them and keep them at a pretty cool temperature. You basically create oil and gas
Hmm.
and you also create traps. So the Canadian Rockies is a similar structural, sensitive little mouse, very similar structure tectonic setting to what's happening in this area up here.
Interesting.
So
Okay.
that's a Cretaceous story
Yes.
that was happening far, far away from everything going on down here. And here's your Talkeetna arc all
Right
through.
there. Okay. Well, that's
And so
part of the
where
dam. Yeah.
Ken and Mike and their student are working is right down. Brandon Keogh
Mm-hmm.
is working as Kodiak right down in here, and then also on the peninsula.
I
So this
see.
Talkeetna art story is Jurassic, late Triassic, Jurassic, and it's not associated with Arctic, other than it looks like parts of Ringelia, this Ringelia composite terrain that your people know
Yes.
love
Yeah.
is has some affinities with some of these terrains, and parts of it may have come from Baltica. That's another whole topic, but that's all kind of a Paleozoic story. So I
Yeah.
haven't really gotten into that much myself. I follow it, but I don't worry about it.
Well, I'll tell you what, Sarah, let's stop your share for a second. I love this map. I want to come back to it. I don't know if
Uh-huh.
we're going to go to the San Andreas. I mean, I kind of like what we're doing right now. Whatever.
Okay, but anyway, this is
Yeah.
this is sort of the theme of the day is how to think about Alaska in simple yeah
Yeah.
chunks. Yeah.
So I want to go back to that map, but I think it's important maybe right now talking about your career and spit take. Yeah. How you got started in what color on that map and how many of those colors have you been thinking about and working on, or what's your subdiscipline within geology that's kind of a thread through all of this work that you've been doing?
Uh, Well, my subdiscipline, I guess you would say, it's tectonics, but I come at it more from the crustal scale, in part because I study metamorphic rocks. I mean, I also study brittle faults, but I really like ductile deformation.
Yeah.
That is my field. I
Okay.
started in Blucius. My PhD was on Blucius on Kodiak Island, and so which are related with the Talkeetna Arc.
Hmm.
So I've been thinking about the Talkeetna Arc for a very long time.
Okay.
And so when Brandon and Mike and Ken got funded, I was just like, yeah.
Good.
And Brandon had already done several field seasons on this project. So it
Okay.
was the classic, you get enough data to write a proposal. And then you get funded to do the
Okay.
work you've partially already done. That's the way it works with NSF. So I had that background.
Yeah.
And then as I was studying Bluetooth, I was like, but wait a minute, most Bluetooth that I study, or people study in the Northern Cordillera and even down into California and Baja, are juxtaposed very close to the arc, too close. Like they didn't form that way.
Mm.
We're missing that big gap between where Bluetooth form in a subduction zone and where the arc is.
Yeah.
There should be a sizable gap, tens of kilometers at least, and they're
Okay.
often right next to each other.
Ah,
Why is that? And it happens, a lot of those boundaries are strike slip faults. So that led me into the world of strike slip faults.
can
And there I went to how do we think about Alaska? And I started breaking it up into parts of here's one kind of getting back to arcs, the thought of should I think about where the big arcs are, like Mike Eddy suggested.
mm-hmm.
I thought, well, I sort of did take that approach, only I took it more from the whole, not just the arc, but the whole complex. Like if you have an arc, you have a subduction zone. Can we
Right.
see where the subduction zone was? In some cases, we can't. Some cases, we're lucky enough we can. If you have Lucius, you know you were in a subduction zone. That's the one thing we can be certain of.
Yeah. Yeah.
You can argue whether the volcanic rocks formed in arcs or not, but if you have Lucius, they formed in a subduction zone.
Okay. Man, my head is spinning now. There's a lot. I didn't
So
know.
yeah, so that's kind of getting back to that's how I started thinking about how to break it out.
I
Yeah.
love it. I love it. So it's news to me that you've been thinking about the Talkeetna Arc in particular for a long time. Can you somehow summarize over the course of your career, what was some of the old ideas about the Talkeetna Arc, and what are some interesting questions that have bubbled up recently? I don't know if you're the person to ask, but maybe you are. I don't know.
Yeah, I could take a crack at that. I
Yeah.
think the original when I was working on it, the big debate was um, I would say the polarity of subduction, which hasn't gone away. And it was based on very old data that has since been kind of tossed out by the petrology community. And that was the idea that you could have a predictable trend in composition in arc rocks as you went away from a subduction zone. So if here's the subduction zone, here's your arc, and you have volcanic rocks, close, and then as often with time, they might migrate away from the subduction front. Or people would say now you're changing that interface, the dip of it. But they saw a trend that suggested that it was migrating to the south in present day coordinates. So that would argue in this old, very old 70s version of how they think about arcs, that it was polarity from the north. But that's why I actually started, that was how I think I framed my PhD proposal was, but we have Bluetooth in the south,
Hmm.
don't in the north. And the Bluetooth had some potassium argon metamorphic ages, and they were broadly the same age as the arc. And people said, oh, that's just because they're right next to the arc and they've been reset.
I see.
So I went in and basically said, no, they're not reset. There's a huge fault between them, and that is the border ranges fault. So that's how I
So,
got started on thinking about strike slip faults in, along arcs
sure.
and juxtaposition of Bluetooth. And
Okay.
so that debate of polarity of subduction in my mind, was laid to rest for quite a while until numerical modeling came along. And so that's why you may have already seen or heard about the GSA Today article that Terry Pavlis and Jeff Amato and others we all wrote because we're like, yeah, we have really good evidence, exquisite evidence, we would argue, that there was subduction from the south.
Hmm.
And so the original Siglock-Mihailnik paper they basically said something along the lines of the Lucius were myth. And I was so needless to say, it's my PhD. What do you mean my PhD?
Right.
So I
Right.
wasn't the only one who was a little annoyed.
Yeah. Yeah.
So we wrote that, and they revised their model and they put subduction on both sides. Okay, that's another whole train we could follow. But
Right.
the other thing that really was interesting, and is was the Talkeetna arc built on Rangelia, or was it always a separate terrain and then it collided with Rangelia? And
Hmm.
this comes back to a big theme. So there's, I don't know, should I pull up a terrain map? But
Sure. Let's go back. This is good. Sarah, this is perfect. You're good and you're willing to just kind of go for it. I love it. Thank you.
okay, yeah, I mean,
This is what I was hoping for.
I can talk about Alaska as they say
Yes.
until the cows come home.
But you're
Yeah.
you're happy to just kind of improv here. I
Oh
love
yeah.
that. Thank
Oh
you.
yeah. Like I said, I think about Alaska a lot. The other place I have done a lot of work, and it's similar in terms of its focus, is Argentina. And that has
Okay.
helped me think about Alaska because the exposure is a whole lot better down there.
Uh-huh.
Yeah,
Yeah.
it's desert, so it's
Right. Oh, look
sorry,
at
I'm
this.
just scrolling
I
down,
love
trying to
this.
find, here we go.
Love
I
it.
just want to find, uh, there we are. Let's go right to there. Yeah.
Thank
Okay,
you.
so
Yep.
I'm bringing this up just because it shows all of Rangellia composite terrain, and I don't have a separate slide. I could pull it up quickly because that was the talk I gave in Anaheim last year, was on the
Mm-hmm.
Talkeetna Arc.
Mm-hmm.
But I'll just say from this picture, this basically broadly is the peninsular terrain out here. This is the Alaska Peninsula, so I flipped it on its side, right? And
Okay.
here's the
Yeah.
border ranges fall. So the Talkeetna Arc really runs from about here all the way across.
Hmm.
And there was a Continental Dynamics, which is a huge project NSF funded back around 2006 or 7, I think, somewhere in
Okay.
there.
Yeah.
Maybe no earlier. Anyway, they went in and said, "This is you will go to one of the you mentioned the type a type locale where you can walk across the Moho,
Mm-hmm.
and that's the eastern end of the Talkeetna Arc. So that's right
Okay.
about in here,
Yeah.
and there it is, thought to be on Rangelia. So the question was, what was it originally all built? All was Peninsula just an extension of Rangelia?
Yeah.
Or was there a collisional event that happened that explained basically some widespread deformation in the latter part, which is sort of 160-ish, 170-ish
Hmm.
of the Talkeetna arc? So the Talkeetna arc started around, let's say, 215 as an active volcanic arc now, or plutonic arc, and that's what is Mike Eddy and Brandon Keogh's Ken's project
Okay.
with subduction initiation.
Right.
But that's, aside from all that, we're kind of going off the subject a little, I realize. But the controversy then was there a collisional event? And that feeds into the Canadian view of this boundary between Rangelia, what we call composite terrain, what they call insular. They say that it did collide with everything inboard, the intermontane, at around 160, 170.
Mm-hmm.
People in Alaska say, geez, we just really don't have good evidence for that.
Hmm.
But
Well,
that has stirred this debate of, was whatever collision they think they see, maybe we saw it with Peninsular colliding with Rangelia. But I would say, again, subsequent work, especially a very recent paper by Rick Saltis and Travis Hudson, that just came out, I think, a couple of years ago now in Canadian sites, pretty well debunked that too. They showed very clearly, in my mind, and partly based on the magnetic anomaly patterns, that the Talkeetna arc is built across Rangelia. And it's, in some ways, if I, let's back up and get out. If I go back to modern Alaska,
thank you.
let's look at modern Alaska. I kind of cut it off because I wasn't going to talk about the Aleutian Arc, but
Yeah. Yeah.
yeah, people can visualize where the Aleutian Arc is. It curves
Right.
way up. This is ocean crust out here.
Mm-hmm.
So this could have been the oceanic crust part of the Talkeetna Arc built on the peninsular terrain, which looks like it didn't have really much on it before the Talkeetna Arc was built in the Triassic, maybe some Permian arc, but pretty oceanic. And then Rangelia would be maybe the equivalent of coming on shore to slightly older crust. So our modern Alaska arc comes up all the way up to here, and it's built on semi-continentalized crust, and then it goes off onto ocean crust.
Okay, Sarah, can you stop your share? I'm loving this. I want to clarify a couple of things just for this
Sure.
this
Yeah.
this head right here.
We're kind of gone off on a whole different tangent from where we started, but that's
It
okay, right?
it's good. It's all tied to the Talkeetna. That's going to be the ultimate goal of where I'm heading with all of this stuff. If not this winter, then obviously when I'm up there, I guess
Yeah.
making some videos with Mike and Ken and is it Brandon? I haven't even met Brandon yet. Is that the
Oh,
kid's
Brandon
name?
Keogh. Yeah. Oh,
Okay.
great guy. Oh,
Yeah.
yeah.
Um,
You'll have a
so
fun time.
well, I'm looking forward to it. Were you going to be up there next summer?
I don't know. Haven't got to find money.
Okay.
No,
All right.
no. I probably there's one place I would really like to get to for some field work. So I'll probably try to
Okay.
get to ride on somebody's helicopter. Yeah.
Okay. Well, when I was teaching myself these exotic terrains down here closer to Washington State, I was using a phrase Rangelia and friends. I wasn't really using Rangelia composite terrain, but I was mostly thinking about Rangelia and Alexander.
Right.
I was not thinking about the peninsular. Is that what you're calling it? The peninsula?
Peninsular. Yeah, peninsular.
Yeah.
Nobody does who works south of Alaska. I'll just
Okay.
be honest.
So can you give us a nice little snapshot of, is it really what's in the Rangelia composite terrain and what are the most basic storylines of those individual components within that composite terrain?
Sure. Alexander is the old component.
Okay.
And we do have some of it in Alaska, not only Southeast Alaska, meaning the peninsula, but
Yeah.
in the main, what I call Main Alaska. There's in the eastern part of Main Alaska, we have bona fide Alexander terrain, and there you can see that Rangelia is attached to it by, I'm going to try to remember the date, 280,
Okay.
285. There's a
Yep.
mutually intrusive pluton, and that was documented very clearly around mid mid 90s, early
Sure.
90s.
Okay.
So quite a while ago. And
Yeah.
that before that time, there was a debate how were Rangeli and Alexander related. So that kind of sealed that yes, these at least locally are, as you said, friends, more than friends. Rangelia, yeah, basically said, I'm gonna rest my head on you.
Okay.
So it got more complicated, but we won't go into the complexities of Alexander
Right.
because those are all in Southeast Alaska and Canada, and that's another story. But then peninsular, so the oldest part of Rangelia that we're aware of in terms of basement on Vancouver Island is
Yep.
quite old. And I shouldn't throw numbers out but
Okay.
let's
Yeah.
just say Paleozoic,
Sure. Yeah.
well into Paleozoic.
Right.
And that's some work that students of George Garrels have done in the last just couple of years. Dan Alberts is the main person who's worked on that for his master's. So then in Alaska, we don't have basement older than the Scolai, which is Pennsylvanian.
Okay.
Okay, so we have a Pennsylvanian arc, and that's sort of what we think of as basement of Rangelia. And we're going to ignore the fact that there's detrital zircon that are Precambrian.
Sure. But it's
Okay.
some oceanic volcanic out
Oceanic
of the
volcanism.
Pacific
Yeah. So
someplace.
there's, at least in Alaska, there's not evidence Rangelia was built on anything really old.
Okay.
Maybe Neoproterozoic locally where it overlaps with Alexander. So Alexander has some Neoproterozoic basement. Then you head west and you have this younger arc, the Triassic arc, the Talkeetna.
Hmm.
And it's primarily on what we call the peninsular terrain. And that's basically the extension. Again, if you really want, I can pull it up from a figure from that talk in
Sure.
Anaheim. Would that
Sure.
help?
Yeah. You got to
Okay, let
scramble a
me,
little bit on your desktop. Yeah.
I
So,
can, it won't take me long
okay.
to
Well,
find
viewers,
it.
let me talk to the viewers while you find
Sure.
that. This is I think the crux of what I'm thinking I want to do. And we might finish this conversation with Sarah going back to some strategies I might use this winter, but I have to spend a bunch of time on the Rangelia composite terrain. And so this is really where I think I need to go. And so it sounds like I'm going to learn for the first time some stuff about this peninsular terrain and its importance. And then, yes, if you didn't catch subduction polarity, that simply means a debate that still is going on about if you have everyone's agreeing we have an ocean plate diving beneath another plate, but the question is it angling towards North America as it subducts? Is it angling away from North America? You're like, why would you talk about angling away from North America? Well, there's reasons tying to some geophysics in the lower mantle and other field geology on the surface that seems to um, point in that direction as well. How am I doing, Sarah?
You're doing great. I'm doing a fast scan,
Okay. Good.
trying to find the best.
Okay.
Okay.
Yeah,
Okay. I think I've it's not quite the slide I wanted, but it will do.
it'll do.
It'll do. Now I have to just find you again. There you are.
Okay.
Lots of screens open. Okay.
Nice.
Yeah, it doesn't I don't split out on this slide. Um, Rangalia versus Peninsular, but
Okay.
I do show where the arcs, Talkeetna
Oh,
arc.
good. Good, 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 good. Yes.
Yeah, so I think that is uh probably what you're looking for
Yes.
and the time period. So all again, I just lumped for the purposes. This is for your viewers. I gave a this was actually an invited talk in a Mesozoic um, session in Anaheim, our GSA Connects last fall, and
Hmm.
I said, "Great, I would be happy to review information because I haven't kept up, in terms of really thinking in depth about the arc. I'm, kind of keep tabs, and there's just so little done on it, quite honestly.
Right.
It's not hard to follow the literature. It's sort of sad that way. But
Yeah.
there's been quite a bit more on the Bonanza arc, which is it's I would say beyond kissing cousin. I would say they're twins. That was one of the points that came out of this talk, putting it together.
Okay.
The person who spoke right after me spoke on the Bonanza arc, and it was just like you could just put these two arcs stratigraphy next to each other, and they match.
Hmm. Okay.
So that's another topic of how did they get separated because we don't have any arc of exactly that age in between.
Ah,
So that's another that was the topic of a whole Penrose practically in
right.
1999 in Winthrop,
Okay. Okay.
way back. So that's an old subject also. I mean, these are basically we were kind of retreading a lot of old subjects, but with a lot better data, which is fun.
Better, yes. And so the outline of the Talkeetna on your map that we're currently looking at, am I hearing you say that part of that Talkeetna is on Rangeley and part of it is on the peninsular?
Correct. So this part is broadly peninsular and this part is broadly Rangelia.
And peninsular was an oceanic island arc that was separate from this original days of Rangelia, or are you saying they're
Well,
potentially the
I think
same?
that my idea is been cemented more firmly by recent work again of Saltis and Wilson or not Wilson, sorry, Rick Saltis and Travis Hudson,
Hmm.
that this was built kind of like the modern Aleutians, as if think of Rangelia like this modern margin of Alaska,
Yeah.
then the rest of Peninsular is new arc forming out on ocean crust.
Okay. Okay.
And it may have gone back as old as the Permian, but we we don't really know much about it when you go off here because it's covered up by other, young volcanics,
Sure.
basically, the modern arc. But you can trace it. It has a very distinct magnetic anomaly signature, and that's what Rick Saltis is a geophysicist who studies especially magnetic and gravity anomalies and heat flow. And so he shows really well in this recent paper, I think, that there's just this dead-on signal that you can associate both with Rangelia and Peninsular, and the signals are different. But
Uh-huh.
you can see how they extend quite a ways. I think the title is something like Rangelia, there's more than you thought.
Huh. I mean,
Something like
that's
that.
wild. Yeah, I was just
Yeah,
on
it's wild.
Vancouver. I was just up.
So
Yeah.
So
Um,
the reason this is important and the reason
okay.
I feel a little defensive about saying, not defensive, but it's sad to say that most reconstructions, when people use Baja BC, they don't include peninsular and they don't include full Rangelia. So they stop it right about here.
Okay, let's stop your share. This, I think we're gonna end here. This feels big. Um,
So
you
yeah,
brought up
so
you brought up Baja BC. I'm obviously still quite interested in developments along these lines. Can you say what you just said again?
yeah,
Peninsula doesn't seem to be including peninsular terrain is not helpful, or
it no, it has to be done and it hasn't been done.
why do you think it hasn't been done? Has it been paleomag done on it?
Yeah, yeah. Um, honestly, I think that'd be a question for Daryl Cowan
Okay.
because his reconstructions, I think Daryl's first reconstructions did not include it.
Hmm.
And I think most people who work on the Baja BC question have not worked in Alaska, and so they didn't question the dimensions of Rangelia.
Okay.
And I've asked Daryl, I mean, I've known Daryl since I was a grad student,
Right.
and we've had many discussions.
Yeah.
And I've asked him why he doesn't include Peninsular.
Hmm.
And I can't honestly remember his answers, but
Okay.
I think it's important because of the problem of now we have a whole lot more real estate to move. And it's a much longer chunk. But
Hmm. Wow, this is okay. It's getting juicy here at the end, at least for my head. Like I think my so we're gonna finish on a real broad scale,
sure,
Sarah.
sure.
I was I was planning on going to Alaska this winter, but not starting in Alaska. I think I wanted to start talking about what I know down here in Washington and then moving so much of this stuff north, whether you're just restoring strike slip faults or you're truly going beyond that and involving paleomag. And I
Right.
just was assuming that Alaska is the main storylines of Alaska depend on what's going on down here. And
That's correct. I agree completely. Yes.
so,
Yes.
so that seems reasonable to
Yeah.
try to connect major storylines down here through BC, through Yukon, and then up there.
Yeah, I would say let's revise that. Everything, from central Alaska south.
Okay.
Right. We're northern Alaska is not part of that storyline.
Why not?
You want a slide? Or
Sure,
word?
sure. Why not? Like,
Okay.
like it,
It came out of the Arctic. And
oh. The AA, the slightly darker shade of blue on that map we were looking at.
yeah.
Okay. All right.
Wrong slide.
I don't think it's worth it. Let's stay out.
Yeah, that's another whole topic for
Yeah.
another day.
Yeah.
Yeah. But
Okay.
yeah, so that's sort of the theme I have, probably the more controversial of the themes I've picked up in the last few years is there's a, and I'm not the first to say this. John Oldow said this in the 1980s
Okay.
in Abstract, and he'd worked in the Brooks Range a lot. He said there's a major boundary running through Alaska, which is the boundary basically between everything that participated in the Arctic Alaska origin and everything else. And he just kind of tossed it off like that. And I was like, huh, I wonder what he means. And then I had the good fortune to be working with people like Bill Patton, who spent his whole career working up in that area. And he was very great person to talk to. And he just said, oh, yeah, I think it's this fall. I'm like, oh, okay. So that's,
So
that's
that I'm going to continue to, I think, follow that there's major strike slip faults, fine, but one of those major strike slip faults is the delineation between uh, stuff that's sliding north to southern and central Alaska. But once we get across that line,
yep.
what fault is that? Is that the
It's
Tintina?
it's not just one fall. And so
Oh,
I am going to share my
okay.
screen
I keep
because
wanting to wrap this up, but at the same time, I don't think I can wrap it up. This is good
no, I'm
here,
not going to let
Lee.
you know, because
Oh, you got me now.
now you got me on my favorite subject, one of my favorite subjects. Yeah, there's no question. This is an arm wave, that I presented it at the Penrose, but nobody there really studied Arctic, so they're like, whatever.
Okay.
Um, yeah. So this is a hypothetical fault that has since been extensively rearranged. But the way I thought about it was, okay, where are all the pieces that I can associate with this Arctic-Alaska
Uh-huh.
collision of an arc and a continental margin?
Yes.
And these are the pieces I feel quite confident these arc basins and continental rocks.
Hmm.
These rocks, farewell, this is continent. These show absolutely like nothing was going on while all hell's breaking loose in the Arctic. So
Okay.
this idea of a transform comes back to, we put this in this paper. There's an old transform boundary. I would suggest, I'm not, again, the only person who suggested this,
Right.
between what's going on down in a Regalia collision world. Here's Rangalia, here's
Uh-huh.
Montane.
Yeah.
This was from this paper where we just said, here's some ideas of how this basin closed.
Yeah.
And then we have a transform boundary and a subduction zone polarity difference at 150. And then what really set me off on this line was this paper in 2020. I was like, bingo.
Hmm.
There's a lot of models for how the Arctic Ocean opened, and especially the Canada Basin, and most of
Hmm.
them involve a lot of rotation. They looked at magnetic anomalies in the Canada Basin, thanks to polar ice cap melting. We can now go out there without icebreakers. So they had this model where it was a transform boundary. And I'm like, look at that. I like
Yeah.
that. So I said, okay, there's our transform today, but it's hatchered because this was left slip. I'm getting back to Trevor's theme, left slip and right slip.
Right.
These are all right slip faults. So
Uh-huh.
our buddies, Denali, Tintina, this is the Kobuk. These are all, Tintina and Denali are huge, huge strike slip fault systems. And then splays off of them.
So
And
why is there some Alexander in the Rangelia and Friends if it's Baltica? Is the AA all Baltica as well?
um, I'm not, there's parts of it up here that I think people would say or out here that I think people would say might be Siberia. I'm not, I
Okay.
think these are like Paleozoic connections.
I see. I see.
These were all assembled by the time this collision was happening.
Okay.
Yeah, so the Baltica origin is a Paleozoic story.
Uh-huh. Yeah.
By the late Paleozoic, these were most of these components, at least Arctic Alaska, were probably along the North America margin on the northern margin.
Huh.
And Bill McClellan had a very recent paper, GSA Today paper on that.
Wow.
And so and there's other people who've written about that extensively. So that's by this time we've got this arc collision. This is part of North America, but not in this orientation. It
Yeah.
was somewhere else. And that's the debate is, did it get there by rotation or did it get there by strike slip
Yeah.
or
Yeah.
some combination? And I'm starting to come down pretty hard over the years on the strike slip model for a number of reasons. But
Huh.
so basically there isn't one fault anymore because it's been offset by all these other faults.
Huh.
And probably locally reactivated, like this boundary that I think started as left slip probably has been overprinted by dextral slip. Similarly down here, this is known to be a late Cretaceous strike dextral fault, but I think this is very hypothetical what's going down here, and it's great that Trevor's working there because we just desperately need
Sure.
data down here. We just have so little information. Anyway, so that's that. So if, like I said, if you want to keep it simple and focused on Baja,
Yeah.
you pretty well don't really have to think about um,
Yeah.
that.
Yeah. Yeah. Although
You can kind of like, you know,
I
until it gets hatchered up by all the other dextral faults.
Right. Well, if you stop your share, please, we're going to say goodbye, but I wanna be direct with you here. Like I'm encouraged. Like the number of people I've talked to who are trusted friends and all that, they're like, oh my God, Alaska, you're
What
going
are
to
you
get blown
thinking?
out of the water. Like, I don't know how you would even start. And occasionally I have moments like that. Like, this is way too much. I don't know what I'm trying to do. I'm not even talking about Alaska, but I'm talking about Washington to Alaska and everything else. But this is perfect timing for me, Sarah. Thank you. Like this is exactly the sweet spot that I'm looking for. Obviously, there's tons of complications, but especially that last 10 minutes, I'm going to be chewing on that. And I don't know, maybe I will want to compare the North versus the South and keep going back to these two major storylines. I love that. And this is just the start. I'm probably not going to stay away from you. I might come back.
Fine. Like I said, I've got so many slides I could share.
Oh God, this is
Yeah, like I said, the color I agree that absolutely simplifying it with color is
yeah.
critical because otherwise you're just your brain hurts, right? It's just
And
hopeful.
all the names and all,
Oh, no,
four
don't go
names
there.
mean the
Don't go
same
there.
thing. Yeah,
Don't do
yeah.
it.
Come on. Okay. Well, hold the line, please. I'm going to stop the
Sure,
recording and we'll chat for a couple more minutes. But
sure.
Sarah Roeske from UC Davis, thank you so much for your
You're
time today.
welcome. Very
Okay.
fun.
All right. Bye-bye.
Bye-bye.